Beyond what we already know about interpersonal coordination in sports, there is still a gap concerning how interpersonal synergies are formed during the course of a sport's actions. Before moving on, let me explain you what do we mean about interpersonal synergies. Imagine that we have two players, and for some reason they need to adjust to each other. They reciprocally adjust to each other to stabilize a performance goal. When this happens, when both players adjust to each other and they can stabilize a performance goal, a synergy was formed, which means that these two players behave as a single entity. So the title for my talk today is to dig deep on interpersonal synergies in sport, and it is related with the research that I have done in the last decade regarding this interpersonal synergies issue. So when we watch a football match or a basketball match, when the players need to pass the ball to each other, or a rugby match, when they also need to pass the ball to each other to keep moving and keep running towards the try line, there is one question that always emerges, which is, are they really coordinated to each other? Well, we can assume yes, they are coordinated to each other because most of the time they succeed. The thing is, or the main question is, how are those players coordinate to each other? So in the last decade, to help us to solve these questions, we were blessed by the improvements in technological devices. We were blessed by positional data. Nowadays it is possible to use GPS devices to capture players' positional data on a football field or on a rugby field, but it is also possible to use some kind of radio frequency devices to capture players' positional data on indoor facilities such as badminton rallies or a basketball match. Also, the improvements in video recording allow us to capture players' positional data plus the ball. So nowadays, fortunately, we can capture the players where the players are on every moment of the match. But this huge amount of time series data can also be a curse if we do not know what we are looking for. So the main questions that I have on these moments was, what variables can contribute to interpersonal synergies formations in collective and dyadic sports? So the first research that I have done with this concerning this theme was regarding the ball carrier and the support player interpersonal coordination in rugby union. In a 2 versus 1 situation, as we can see by the video, there is a ball carrier. When we get closer to the defender, he will pass the ball to a support player who is managed to run the velocity, maintain a certain interpersonal angle to receive the ball and keep running towards the try line for a beautiful try. So it seems that the performance goal of these players is how to manage the relative positions in order that in the moment of the pass, the support player can capture the ball, can receive the ball while running. So it seems there is some kind of interpersonal angle between them that may work as a performance goal. So this performance goal can describe the interactive behavior between the ball carrier and a potential receiver. But then we have another question, is how the players can regulate this interpersonal angle. Well, what are the task-relevant elements that might contribute to stabilize this interpersonal angle? Now we can see that both attackers are running towards the try line. However, they need to regulate this angle. To regulate this angle and keep the desirable positions, they need to manage the running line velocities. So it seems that the players' running line velocities are good candidates to task-relevant elements. So what do we have so far? We have an interpersonal angle, which is a performance goal that players need to stabilize and maintain during the course of an action. But then we have also task-relevant elements, which are the elements that should be left free and the players need to manage in order to maintain a relative position which is captured by the interpersonal angle. So what we need to show evidence is regarding the linkage between the task relevant elements, the adjustments on each player running line velocity in order to stabilize the interpersonal angle in the moment of the pass. For that purpose, we use a concept that was developed in 1999 by Schoner and Scholz called the Uncontrolled Manifold Hypothesis. We develop and create a mathematical application, a computational application based on the UCM hypothesis. And the hypothesis that we have is that the control of the dyadic behavior is on the interpersonal angle. This is the main control. Players' velocity should be left completely free in order that players can adjust to each other in order to stabilize the angle in the moment of the pass. So this is the results that we have for this research. We can identify 19 out of 55 trials, about 34% of the trials, we can identify players' interpersonal synergies between ball carrier and the support player in order to stabilize the interpersonal angle in the moment of the pass. The UCM, well, it has some challenge. There is a mathematical challenge and computational challenge to use the UCM. However, the output is quite easy to understand. Values above 1 means we have a synergy. Values below 1 means there is no synergy. So we got 34% of synergies regarding ball carrier and support players, adjustments to stabilize the interpersonal angle in rugby union, but for the other 66%, we do not know what happens. Perhaps they formed interpersonal synergies with different variables than the running line velocities and the interpersonal angles. But at this time we have a concern. There is a limitation of the UCM, which is a dependency of the reference value. We said for this study the reference value was the angle between the players in the moment of the pass. But we would like to move a little bit forward and trying to, well, solve this limitation concerning the dependency of the reference value. So we move on to a different context. We move on to analyze the hypothetical interpersonal synergies between badminton players within the same diet. And when we watch a badminton match, badminton rally, we can see that the players adjust to each other to maintain a certain interpersonal distance. By maintaining this interpersonal distance, they avoid an attack of the opponent team to the middle of them. So in other words, players' interpersonal distance seems to be quite important because players within a diet, they need to fill the court, avoiding the attack of the opponent team to the middle of them. So the interpersonal distance, it is now our performance variable, something that the players need to stabilize during the course of a rally. To do this, players' velocities are a good candidates to task-relevant elements. So they need to manage the velocities in order to maintain a relative position, in order to stabilize a certain interpersonal distance. Again, we use the UCM as a concept, the uncontrolled manifolds, but now the hypothesis changes a little bit. The control of the dyadic behavior is on the players, not in the angle, but in the player's interpersonal distance, where player's velocity, again, should be left free. And the results point on this direction. We have a percentage of 50, 40, 40, and 32% of interpersonal synergies during several rallies. So these results were good, but still we need to analyze and trying to find out, identify the interpersonal synergies for different values of performance variable. So we ran the UCM and we use different reference values to see if it is possible that the same diet within the same rallies can form synergies, but with different reference values. And by the results over here, what we can see is that double one can form a synergy over here, which means that players adjust the velocity to maintain a certain relative position, but now they can get synergies for values close to 1.2 meters of interpersonal distance. Whereas for a different rally, the same players on the same match can also form a synergy, not for 1.2 nor 2 point something, but for 3 meters. They stabilize the synergy on 3 meters of interpersonal distance. So these results lead us to suggest that it is possible that the reference value for the performance variable, it is not a single value, but could be a range of values. But we need to prove this. The same is true for double 2, double 3, and also double 4. We identify synergies close approximately 50% of the rallies. We are happy, it's okay, good, but what about the other 50? What happens to the other 50% of the rallies where with these variables of interpersonal distance and the players' velocities, we could not identify the interpersonal synergies? At this time, we create an hypothesis, which is there is always synergies formation. When the players go to a pitch, or no matter if it is a rugby pitch or if it is a badminton court, as long as we have the need of interpersonal coordination, we have synergies formation. So the question is, we just need to identify how these synergies were formed. So when we saw players within a badminton court, what we can see is that players move on the horizontal axis, but they can also move on the transversal axis. And they can use different combinations of these movements to stabilize the interpersonal distance among them. So we remain with the interpersonal distance as a performance goal, but then instead of using only the player's velocity as task relevant elements, we use the coordinates of player 1 and player 2 on both axes, the coordinates of player 2 on both axes, and the velocities of each one of the players on these axes. And with this, what we are trying to display here, it is a portrait of interpersonal synergies along the set of rallies. What we can observe with these results here is this. Dyad 1, for instance, can form 25 out of 35 rallies. They can form 25 interpersonal synergies with the player 1 adjustment on the transversal axis with the player 2 adjustments on the horizontal axis. When they do this, they stabilized the interpersonal distance between them. But it is also true that the same players of the same dyad can form 25 out of 35 interpersonal synergies using player 1 adjustments on the horizontal axis and player 2 adjustments on the transversal axis. So it seems that players can form synergies using different dimensions of displacements. And then we have another question. What about the other dyads? The guys who were in the other side of the pitch, the opponents. Is it possible that in the same match they display a similar portrait? And they are not. They are different. For instance, on dyad 2, they can form 29 interpersonal synergies out of 35 using player 1 adjustments on the transversal axis with the player 2 horizontal axis. Well, this leads us to suggest that probably interpersonal synergies formation is unique for each match, but also it is unique for each dyad. One question remains: is it possible these kind of portraits for each one of the dyads remain along a set of matches? Is it possible that if instead of analyzing a single match, if we analyze, for instance, 10 matches for these dyads, is it possible that this pattern, this portrait remains? That is an issue for further research. So interpersonal coordination, it seems it is always supported on synergies formation. The control over the dyadic behavior is on the performance goal, on the interpersonal distance, or in the interpersonal angle, where the task-relevant elements are left free to adjust to each other to stabilize the performance goal. But now we have a different question. Synergies can be good or bad? This raises a question regarding a potential relation between synergies and performance indicators, or identify synergies with certain kind of outputs. We ran an exploratory study trying to find out synergies in football. Again, quite similar to the badminton study, we capture synergies between dyads of players, player 1 and player 2. Here we form a synergy, these two players another synergy, and these two players another synergy. Similar to what happened to the badminton study, we assumed that an effective defensive strategy means that the players need to remain within a certain value of interpersonal distance, avoiding an attack of the opponent team to the middle of them. They need to fill the space between themselves. So this is true positional data, real positional data that we have. Here, dyad 3, dyad 2 in the middle, and dyad 1 over there. And then you will also see the red dot displacement, which means ball displacements. And the results I would like to address, this is very, very, very exploratory data, because we have a few data of these. And what we can see is that the UCM values all above 1, which means there is synergies between player 1 and player 2, player 2 and player 3, 3 and 4, the dyads. And what we can see is that the ball displacement never crossed the defensive line. This might lead us to suggest that probably, due to the synergies formations between the defenders, the ball carriers, or the attackers, cannot see any possibility of action to put the ball close the goal and put the ball crossing the defensive line. However, if we analyze a different situation, we can see that dyad 1, which means these two players of here, they do not form a synergy. And as we will see, the ball will cross the defensive line and right over here, where the synergies could not be formed. So again, I know this is a very, very, very exploratory data, but it seems to suggest that probably there is a linkage between synergies formations and performance indicators. We cannot conclude anything about this exploratory study. We only can extract a few hypotheses and motivation to keep going, trying to find out this linkage. What is the relation between interpersonal synergies formation and dyadic collective performance? This is what we are looking for the next decades, we hope. But we have some limitations regarding the UCM, the uncontrolled manifold. There is always the dependency of a reference value. It remains. Yes, we can use different values of performance variable, trying to find out synergies. We are working on it, but this dependency of the reference value of the performance goal remains. It cannot capture the fluctuations on synergies formation. It is true. When, for instance, when we have the final result of a synergies formation on a badminton rally or on a rugby situation, we have a single value. Above 1 we have synergy, below 1 we do not have synergy. But we do not know what happens to these synergies formations along the course of a rally or along a 2 versus 1 situation in rugby. We do not know if for instance, in some moments there is a synergies formation with the UCM values above 1, but then in the different moments of the rally, this synergies formation disappear and then it comes back again. These dynamics we could not capture yet. So issues for further research. Is there a pattern for synergies formation? That portraits that I show about the badminton rallies, is it possible that that portraits remain along a set of matches? Also, There is an unexplored linkage between synergies formation and performance indicators. The question that I placed before, are synergies good or bad, and what situations they can be considered good synergies or bad synergies. Also, how synergies evolve during the course of an action. This is one of the main issues that we are working now is on the dynamics of interpersonal synergies along the course of an action. Thank you very much for your attention.
And we're back, and we have Pedro joining us. Good morning. Good morning, Pedro.
Good morning.
I can see you, I can hear you, and we have just heard your wonderful talk. And I'm so grateful to you for having pre-recorded it. It means that I can watch it over and over again. And I have a question directly from Travis Wiltshire, who is joining on the YouTube. He says, hello, everyone. Quite an interesting talk, Pedro. Do you ever imagine whether opposing players form a synergy with each other? And he stole my question.
Yeah, okay. Good morning, everyone. And thank you, Merle. Thank you, Travis, for the question. No, we do not examine whether opposing players can form a synergy yet, but is obviously in our plan. However, we have a conceptual issue surrounding these opposing synergies, which is to create synergy, players need to adjust to each other. They have the goal to adjust to each other to stabilize something. The problem is when we have opponents, they do not want to, well, adjust to each other to stabilize a goal. So it is a conceptual issue regarding what is a synergy formation. However, I think we can overcome this issue. And probably there is some kind of non-intentional synergies or something like this. At least for when we watch, for instance, rugby players or football players, I think that the ball carrier wants to disrupt the synergy, a potential non-intentional synergy, whereas the defenders wants to maintain the synergy in order to stabilize, for instance, the angle between them, covering the path, the trajectory to the goal. So it is possible that we can find out. Mathematically, it is possible because we are working with coordinates, so we can run the coordinates in the MATLAB routine, and probably we will find out UCM values above 1. The thing is, how can we defend the existence of a synergy between opposing players? That is my doubt yet. Thank you for your question.
Yeah, it's really important actually for us to bear in mind, you know, why would you look for a synergy between a person? I do see your point. I did have another question, which is again maybe conceptual, but is, you know, the reason one would want to have a synergy with your teammates is assumedly to win. Do you ever look at whether greater synergy, comparing, because you did do synergies for each of the two badminton pairs, did you see whether greater synergy between a pair resulted in actually winning the match? Is it a good predictor of better performance overall?
We have no idea. That is one issue for further research. Exactly, is trying to relate synergies values with performance indicators. But concerning the result, the final output of a match, there is an incredible amount of variables that can influence the final output. So synergies are only one. Perhaps we can find out some kind of relation between synergies formations and performance indicators. For instance, if players in the badminton court have the goal to maintain an interpersonal distance, and by maintaining that interpersonal distance, there is less attacks from the opposing team to the middle of them. Okay, this can be a relation. We can find out a relation here between a synergy formation and a quite specific performance goal. But it is difficult. I think it would be difficult to find out any relation between synergies formations and the final output of a match. We are just starting using this concept now. I think we are in the beginning of exploring how can we measure synergies. Perhaps within 10 years, we can find out some kind of relation with much more data, much more results, and a different techniques. Not only this one. Okay.
I think that's a fair point. We have another question coming. So first of all, Carlotta Torrance says it is difficult to think in synergies without the same task goal. And so I think she agrees with you.
Yes.
I would also say though that one could theoretically also break down a game, a match, into mini goals, right? Most group coordination experiences are maybe have an end goal like winning the match, but there probably are interim goals which are perhaps even more important. And you might see a better coupling between a synergy during a particular block and then that end goal. But I must get another question from Rodrigo Santos, who says, considering that synergies are context and scale dependent, is it possible that synergies between opponents may be supported by the task goal of giving rise to the purpose of the game itself?
Well, Rodrigo, we need to talk to each other later. Be supported by the task goal of giving rise to the purpose. It depends of what you mean by the purpose of the game by itself. And I think going a little bit backwards to relating the synergies with the output, it also depends on the specificity of each sport. For instance, in a basketball game, the result is continuously changing. So it might be easier to find out some kind of relation between synergies formations and the changes in the output, in the results. Perhaps in that sense, we can find out how to analyze synergies between opponents and then relate with results. I don't know. This is issues for further research. There is a lot of questions. I used to talk with João Milho when we are working and thinking about synergies, that as much as we work, as much as we think and write and read about synergies, more questions we have, which is good. But most of them, we need much more time to solve them and to answer. But anyway, thanks for the questions.
It's the difficulty of working with a more complex model, right? There's a reason why some of us less ambitious are stuck on finger tapping, because, you know, in the real world, it becomes that much more complicated. And what you'll probably find is that you're going to need nested models. You're going to have much more complex ways of putting the things together. I'm just checking. Travis has said something, but it isn't a question. So maybe you can go and read the train of thought there. But we'll let you go back to your teaching. Pedro, thank you so much for your time and for sharing your talk with us today. And we will hopefully be in touch. And if you have any questions more for Pedro, maybe you can just drop him a line.